Hey, so I was having trouble with Collaborate Meeting, and I'm creating this video on YouTube instead. And I guess I'll just get started. So my name is Talvon Brown. I'm a third year mechanical engineering student at Drexel, and moving into my fourth year in the fall. And my project is Real Virtual Reality. So this is just explaining some things you can expect moving forward with the project, and you can expect to hear about the goals of Real VR, the reasons for creating Real VR itself, and problems associated with creating Real VR. You can also expect solutions to these problems, benefits for creating a project, and also cost and project overview and timeline overview, and also future possibilities for the project in post production. So the major goals of VR were to create a VR experience that was more based in the environment the user is currently in, and it'll bring the VR experience to that world instead of placing the user in another world to experience what that world has to offer. And I think one of the major things I want to do with this is use motion sensing technology as a major control aspect of this. So you'll be using your body instead of the controller itself to make the controls more intuitive, maybe even decrease a learning curve associated with some aspects of the technology. So some major things I would like to see the project be able to do are to interact with things such as social media, email, apps, and maybe even games. So some problems associated with this were the fact that most VR currently in the world available are all based on placing a user in another world. And I think what I want to do is get rid of that aspect and use the real world, augmenting the real world and the reality the user is currently in. And I also want to remove the controller aspect of virtual reality technology and gaming. The major problems associated with that could be things such as costs, so funding would be a problem, the space for experimenting, making the two technologies compatible, the two technologies being virtual reality and motion sensing, and a lack of existing knowledge on the subject already. There are products that exist that do similar things with integrating motion sensing and VR, but there's not much information available for them currently. And there's also a problem related to my lack of coding experience, and some solutions to those problems could be things such as Drexel could fund the major costs, so the major hardware, and that could be the motion sensing technology. It could also be the VR technology. Also, Drexel could provide ability to use their labs and engineering labs, and this could decrease the costs associated with experimenting and testing. And to get at the problem involving the lack of compatibility for the two technologies, I could have a bunch of the initial research be focused on making sure the two motion sensing and VR technologies will be compatible. So some benefits involved with creating a project could be the ability to augment the user's reality. It could also be the fact that this VR technology is a new type of technology, doesn't really exist yet, and it could also be the experience I would gain when creating this project. So this is just an overview of the hardware and software that I could expect using moving forward with the project. And the hardware would be the VR hardware, which I've narrowed down to the two major sources. And this could be because I looked at the availability of information for the two projects, and also because I looked at the cost of the two projects, and also if the VR functions well. So these two that I have currently are Oculus and Asus. They are two major creators of VR currently, and they have the best functioning technology. Kinect is the motion sensor technology. It's being used in most current gaming platforms that involve the use of motion sensing to control features of the game. Oculus and Asus each come with a compatible PC that really make it possible to run the programs itself. And software programs are more flexible. They may change depending on what route I decide to take, but these can involve things related to the relevant coding programs, the relevant engineering platforms, and the relevant engines for running each program. So this is just a cost overview. I think the biggest thing here is to focus on the fact that there are three major possibilities moving forward with the project that I've narrowed down to. And this could be using an Oculus with the Oculus Ready PC for a total cost of around 1,700. Asus with the Asus PC for a total cost of 1,650. And I could also build my own PC for Oculus, which is the cheapest price, but it also comes with the most manual labor, and it may be cheaper overall to just move forward with buying a PC that comes ready for this. So this is just a project timeline. I think the biggest thing it overviews is the importance of each portion of the design, and you can see I put most of the time into performing experiments and the second most time into things such as compatibility and final touches for making the project work. So I think in the future you can expect a lot from RealVR because I think it sets a basis for things to expect with augmented reality in the future. Um, I think the technology itself is really customizable, and in the future, the user can define what the body will control. It could also decide what features to include in the technology. I also think Real VR is expandable and it can be implemented to have new features, new games, new ways of experiencing virtual reality technology in the real world. And this is just a slide for questions. I'm not really sure how this will work through YouTube, but post the questions you may have on Blackboard Learn and I'll respond to each of them. And lastly, this is the works cited. Thank you.